Assalamualaikum. Okay, so today we are going to go to the title of interval of convergence, where the interval convergence use the ratio test limit n approach infinity an plus 1 over an. They must have the modulus on the both side. So let's say you have a question, determine the interval of convergence for the series where the series is x minus 2 to the power of n over n multiplied by 5 to the power of n. So since we are now using the ratio test, so we have to identify the an and the an plus 1. So here the an is the question itself, while the an plus 1 is you put the n here to become to be n plus 1. Here is the n plus 1, and then 5 to the power of n plus 1. So after that, you substitute the x minus 2 to the power of n plus 1 over n plus 1 multiplied by 5 n plus 1 multiplied by, since this one is the division, so the n5 n will be at the upper level, at the upper, and then the lower will be x minus 2 to the power of n. Okay, so continue from the ratio test. So we use the limit n approach infinity an plus 1 over an. So here the limit n approach infinity is the x minus 2. Okay, continue from the previous, where we use the limit n approach infinity an plus 1 over an. So we substitute the value of an plus 1 and an. And then we expand the x minus 2 to the power of n plus 1 to become to be x minus 2 to the power of n multiplied by x minus 2 over n plus 1. So here we can expand also to become 5 to the power of n multiplied by 5 to the power of 1. Here we just does not need to expand anything because they have no expansion here. And then we cancel. So x minus 2 to the power of n cancel with the x minus 2 to the power of n, and then the 5 to the power of n cancel with the 5 to the power of n. So here we left with the x minus 2 multiplied by n over 5 n plus 1. So if you see here, the limit is for n only, so that's why you have to put everything which is not n outside the limit. So here I put the value of coefficient 1 over 5 and x minus 2, don't forget the absolute value, and then I left the limit n approach infinity of n over n plus 1. So to solve the limit of n approach infinity n over n plus 1, we use the L'Hopital's rule, because when you substitute the limit n approach infinity n over n plus 1, we get infinity over infinity. So by differentiate the n, we get the 1. Differentiate the n plus 1, we get 1. So we get the value of 1. So here 1, so we get the value of 1 over 5 multiplied by x minus 2. Why we have to let the x minus 2 with the modulus? Because we want to find the intervals. So here, the interval of convergence is the 1 over 5 x minus 2 with the modulus must be less than 1 to be convergence. Remember, to be convergence, there must be less than 1. So follow this method, and then you multiply the 5 with the 1 here. So you get x minus 2 less than 5. And then to open the modulus is positive negative, so you get negative 5 over here and the 5 over here. Okay, and then after that negative 2, so negative 5, negative 2, you put it out at the left hand side to be negative 5 plus 2. Here is the 5 plus 2, so that's why you get here negative 3. That's why here you get 7. So your interval is from x is greater than negative 3 less than 7. Okay, so after we've identified the interval of convergence, so we have to test one by one. So substitute the value of the x equal to negative 3 inside the original question. So here we substitute the value of negative 3 inside the x. Negative 3 minus 2 to the power of n over n to the power multiplied by 5n. So here we get negative 5 to the power of n, which is we can expand or we can change into negative 1 to the power of n, 5 to the power of n, and then over 5 over n multiplied by 5 to the power of n. So from here we can cancel 5 to the power of n and 5 to the power of n to get negative 1 to the power of n multiplied by 1 over n. So here, since we get the value of negative 1, this one is the alternating series test. So we have to remember back the alternating series test where they have two conditions that have to be satisfied to get convergence. Where the first one is you have to make sure an is greater than an plus 1. So you have the value of an is the 1 over n. And then an plus 1 is the 1 over n plus 1. And then you substitute the value of an you get 1 plus 1 over 2 plus 1 over 3, and then you substitute the value of an plus 1 over 2 plus 1 over 3 plus over 1 over 4, and so on. And then here when we compare the element, we get the an was greater than an plus 1. So we test for the second condition of the AST for limit n approach infinity, 1 over n. When we substitute the infinity, we get 1 over infinity, which is equal to 0. We satisfy both the condition of alternating series test. So since this one is positive, this one is positive, so this one is converges. And then we substitute the value of x equal to 7 inside the question. So we get 7 minus 2 to the power of n over n multiplied by 5 to the power of n. So we can cancel the 5 to the power of n. We get 1 over n. 1 over n is the P series that have one specific series known as harmonic series, where the harmonic series is always diverges. So you have the final conclusion for this interval convergence, where negative 3 is the converges, while the x equal to 7 is diverges. So interval convergence is have this value for negative 3 and 7, they are open. So the x is greater than or equal to negative 3, x is less than 7. You can write in this type or you can also write in this type.